Good morning class. Today we are going to discuss about coordination number. Students, defining coordination number is defined as the number of coordinate bonds formed by central metal atom and it refers to its coordination number. Okay. So students, suppose we are taking any example like Ni, NH3 whole 6. So for this complex, its coordination number for nickel is 6. Okay, because the central metal atom, that is nickel, is surrounded by 6 ammonia. Okay, that is ligands. Students, generally talking about the coordination numbers, so 4 and 6 are most common coordination numbers. Other coordination numbers are also present, but they are very less common. So students, talking about some examples. So here you can see, talking about the coordination number 4 and 6. Here is the very first complex, that is NiNH3 whole 4 Cl2. So for this, as Ni, that is central metal atom, is surrounded by 4 NH3, so its coordination number is 4. Okay, the coordination number of Ni is 4. Okay, now students, you can see the second example, FeH2O whole 6 Cl3. So for this complex, as Fe, that is central metal, is surrounded by 6 H2O. Okay, you can write it like this, 6 H2O, because here oxygen is the donor atom. So you can write OH2 also. So here you can see that the Fe metal is surrounded by 6 H2O molecule. That's why it has coordination number of 6. Now students, you can see there are coordination number of 1, 2 and 3 also. So these are rarely observed, and basically they are observed in the case of organometallic compounds. Okay, so you can see here students, CuCl2 minus, so here coordination number of Cu is 2, AgNH3 whole twice, here coordination number of Ag is 2, HgCN whole twice, here coordination number of Hg is 2. Now students, as we have discussed about the coordination number of 4 and 6, let us see coordination number of having 5. So in case of Fe, CO5, coordination number of Fe is 5. Okay, so these are the general coordination numbers observed in coordination compounds. So students, sometimes higher coordination numbers are also observed that are greater than 6. So compounds that are up to 16 coordination number are known, but basically they are rare. You can see here ZrF7, TaF8, NdH2O9. Okay, these are the complexes. Students, there is one more thing which you should know. Suppose there is a coordination number of 2, so you can identify its geometry. So for coordination number 2, geometry will be linear. Likewise, you can see here metal will be at the center and the two ligand will approach from at linearly. Okay, in case of coordination number 3, geometry will be trigonal planar. You can see in this manner, metal atom will be in the center, and here you can see the triangular planar geometry. In case of coordination number 4, two type of geometries are available, square planar and tetrahedral. In case of coordination number 5, two type of geometry are possible. One is square pyramidal and the other is trigonal bipyramidal. And in case of 6, the geometry is octahedral. So this is all about coordination number. In our next lecture, we will be discussing about oxidation number and effective atomic number. Thank you class.